Hi guys, today we're going to continue with chemical reactions and organic compounds. We're going to move on to number 2, which is addition reaction. We already saw the first one, which was substitution, and it was really simple. And now we're going to go to addition reaction. Addition reactions happens in a compound that has double or triple bonds, alright? For us to have an addition reaction, we need a double and a triple bond. Why? Because this double or triple bond, it's going to get broken so that the elements that we are adding can get attached. So once I said this, I'm going to give the two basic examples with using letters as substitutes for the elements, and then we're going to do real examples, and I'm going to explain you a rule of Markovnikov that you need to have on mind. So with that being said, I'm going to start with the first example. Remember that R is a chain of carbons. It doesn't matter the number. So I'm just putting this as an example. All right, and my hydrogens here. What is my addition reaction? This is how your addition reaction is going to look. We have double or triple bond, and we are adding something. Okay, so what happens in this reaction? First of all, for me to add A and B, I need to break my bond. All right, I break my bond and I split that. So this reaction is going to look, we're going to have my R, same way, because it's the chain of carbons, my R on the other side. Okay, I broke my bond and I knew I had a hydrogen here and a hydrogen here. So now since I broke my bond, I have 1, 2, 3, 1, 2, 3. So I'm missing one in each carbon. I'm missing one bond in each carbon, and this is where I'm going to put A and where I'm going to put B. And that is a simple addition reaction with examples with letters. And I'm going to make another one with a double bond so that you can see, with a triple bond, so that you can see how it works with a triple bond. With the triple bond, we're going to have the same thing, just that in some cases we're going to have two different outcomes, but it's basically the same thing. We're going to have our R, carbon 1, 2, 3, carbon bonded with R. 1, 2, 3, 4, 1, 2, 3, 4. No hydrogens attached. So when you have a triple bond, you can have plus 2AB, or we can have it plus AB, and we can have two different outcomes. Step 1, break the bond. All right, so here in this first addition reaction, we have R, carbon, carbon, and R. And I'm trying to attach 2A and 2B's. So I have 1, 2, 3, 4, 1, 2, 3, 4. So here goes A, B, B. All right? This is in case I'm adding 2, because remember 2 is going to affect the A and the 2 is going to affect the B. In the given case that I'm just adding AB, the answer would be this one, R, carbon, bond, carbon, R. 1, 2, 1, 2. I'm just missing one bond for each because I just want to add up A and I want to add up B. So what's wrong with this carbon? It only has 3 bonds, but I only wanted to add 2 elements. And I don't have hydrogens. I cannot make up my hydrogens, all right? You cannot invent hydrogens. So this one keeps a double bond, It keeps a double bond. So this is the two types of reactions that you can have when we have a triple bond. If you're adding 4 elements, like in this case, you break it up to a single bond and you add the 4 of them. And when you just have 2 adding, you leave a double bond and you add the 2 elements. I hope these examples are clear. So now I'm going to make an example using exercises. Let's erase all this. And I'm going to put it here. Markovnikov rule. I don't know how you pronounce that, alright? I'm sorry if I said it bad, but Markovnikov rule states that the hydrogen will be added in the carbon that already has hydrogen. Why? Because hydrogens make carbon stable. So if a carbon already has 1 hydrogen, we are going to add the rest of the hydrogen that we're adding in our addition reaction to that carbon. I'm going to explain to you right now what I'm going to try to say here, what I've been trying to say, because Markovnikov can sound a little bit complicated, but it's not once you see it in practice. So let's make this example. Let's say, and this is how you're going to look at it when we are making a quiz or an exam. All right, let's say I have 3-methyl, comma, 2-butene. Plus hydrofluoric acid. Alright, so first let's put this as a reaction. So we're going to have but 1, 2, 3, 4. Why? Because but is 4. E means that I have a double bond on carbon 2. 1, 2. On my second carbon, I have my double bond. Okay? Then I have on my third carbon a methyl group, CH3. And on the rest of them, I'm going to put my hydrogens. 1, 2, 3, 4, hydrogen, hydrogen, hydrogen. 1, 2, only 1. 1, 2, 3, 4. It doesn't have any. Hydrogen and hydrogen. Alright, plus HF. So, I already know that in my addition reaction, I'm going to eliminate my double bond. And once I eliminate my double bond, I'm going to add up the hydrogen and I'm going to add up a fluorine. I'm trying to add 2 elements, so I'm going to eliminate my double bond. So I'm going to have 1, 2, 3, 4. Alright, this one remains the same with 3 hydrogens. This one had 1 here. This one has a CH3 on the top. Alright, I'm going to erase and put it closer here so you don't get confused. And this one had the 3 hydrogens. Alright, so I eliminated my double bond and I need to add up a hydrogen and a fluorine. And Markovnikov rule says that the carbon with the more number of hydrogens is going to get the hydrogen. So I have this carbon and I have this carbons where I can add up hydrogen and fluorine. Here, I'm going to add up my hydrogen. Why? Because this one already has a hydrogen. And this carbon number 3 doesn't have anything. So on carbon number 3, I'm going to add up the fluorine. And this is Markovnikov's rule, because this carbon is going to get more stable because it already has 2 hydrogens. And that's the rule I was trying to explain, what you see over there. Copy it on your notebook. It's a really important rule, because if you put this if you switch them position, it's going to be incorrect. All right. With that being said, we're going to make another example. Let's make a different example. All right. Let's figure we have cyclohexene with a branch right here, and we're adding it hydrobromic acid. I'm trying to use Markovnikov rule, and that's why I'm adding hydrogen, so that you can see these types of examples. So my bond is going to get broken between these carbons. How do I see this? Or we're going to have to make the actual structure, all right, with carbons. And there we go. Here we had a double bond. And this one's the one who's going to disappear. So this one had a CH3. And this one had an H. All right, H2, 1, 2, H2. The rest of them have 2 hydrogens. So when I break this bond down, I eliminate this one. I have another space to add up my hydrogen, which is going to go here, because Markovnikov tells me that if I already have a hydrogen, I need to add it in there. So here I'm going to have a hydrogen too. And then the bromine is going to go to the other carbon, and we're going to put it here. Kind of like a wide looking. Alright, because this one is going to have 2 branches. So by the end, when we make the skeletal formula, this compound is going to look like this. Can't see very well here. And here we're going to have Br, and here we're going to have CH3. And that's how it looks like. That is it, basically. I'm going to make one more example so that you finish to get this topic, and if you didn't, tomorrow I can make another 2 examples or so that you can finish seeing the addition reactions. The book has one example. The book has ethene. We're going to have an ethene. F, remember, is 2. E means a double bond. 1, 2, 3, 4. Hydrogen here, hydrogen here. Hydrogen and hydrogen. And in this case, we're going to add up a chlorine molecule so that you see the other reactions. So we have an ethene plus a chlorine. I know I'm going to break down my bond. So I break it down, and I'm going to have carbon, single bond carbon. My hydrogens that I already had, hydrogen here, hydrogen down. Here I have 2 hydrogens, so I put them. Now I'm going to add up my chlorine. 1, 2, 3, 4. 1, 2, 3, 4. There's 2 chlorines. One goes here, and the other one goes here. So chlorine, chlorine. What's the name of this final compound that we have? 1, 2, fluoro. F. Why F? Because I have 2 carbons. Do I have a double bond? No, so it's an ethane. And that's it for the addition reactions. I hope you understand. If you didn't, let me know, and I'm gonna post a different video with 3 more examples so that you can continue seeing addition reactions.